Hi, in this video we're going to learn about vertical asymptotes and holes on graphs of rational expressions. At the end of the video, you are expected to be able to find the vertical asymptotes and holes of a given rational expression. Let's have a review. Rational expression is defined as the quotient of two polynomials. A rational function is a function defined by rational expression. Here are examples. It should be polynomial or over polynomial. What is not a rational expression? Well, here you can see there's a exponent variable. It's not considered rational. Or there's an absolute value. It's not. A rational function should only have a polynomial on the numerator, a polynomial on the denominator. Now, how do you find your vertical asymptote? If x minus a is a factor of the denominator of a rational function, but not a factor of a numerator, therefore it means it was not cancelled, then equating x minus a equal to 0, you will find your vertical asymptote, which is x is equal to a. It is your vertical asymptote of the graph of the function. It is the imaginary vertical line wherein the curve seems to approach as it extends to infinity. The location is the value on the x-axis, or it's the a is the intersection on the x-axis, a vertical line. Now, let's have example. How do you find vertical asymptote? Given a function x minus 3 all over x squared plus x minus 12, first things first, you need to factor your denominator. 12 has a factors of 4 times 3. Since this is positive 1, 4 is positive, 3 is negative. Now, looking at your factored form, you can actually simplify further your function into 1 over x plus 4 because x minus 3 is cancelled. And therefore, x plus 4 will be your only basis of your vertical asymptote. Take x plus 4, equate to 0. Subtract both sides by 4 and you found your location of your vertical asymptote at x negative 4. If you are going to check on your Desmos calculator, here is your factored form of your graph. If you're going to check, here is your graph. The vertical asymptote is located at x negative 4. As you can see, by default, the vertical asymptote will not show up. This is just to show since x is equal to negative 4, the location of vertical asymptote, and so here it is in blue. Now, the question is supposed to be, if your x on the given function is 3, this factor actually becomes 0. Let's check your 3. Did you see that? It says undefined. And if you go check carefully, when I hit the exact 3, it creates a circle. And that is actually called the hole of the graph. It creates a gap because if x is actually equal to 3, the function is actually undefined. That is why it says 3 and y is undefined. And undefined because the value of 3 as x on the function makes the function undefined. Now, I mentioned that it's also a hole as actually it shows on the graph. Let's go back to your PowerPoint. What is actually a hole? If the factor x minus b, both of the numerator and the denominator of a rational function, and so it is cancelled, then there is a hole in the graph of the function if you equate x minus b equal to 0. B is the location of your hole, unless b is the vertical asymptote. it should not be the vertical asymptote, the other factor, which is actually the one that was cancelled. The exact point of the whole can be found by plugging b into the function after it has been simplified. Let's continue the work. Remember, we found your vertical asymptote -4. To find the location of the whole, we are going to equate your cancelled factor into 0. And then find the value of x, add both sides by 3. And so x is equal to 3. The x-coordinate, of course, of the whole is 3. How do you find the y-coordinate of the whole? We are going to substitute 3 from the simplified form of the function. Because if we use this one, it creates a 0, and so it cancels, and so actually it's undefined. Instead, we will use the simplified form wherein it does not become undefined. So if you plug in 3 on the x, it becomes 3 plus 4, and so it's 1/7. Remember, function is actually y, and therefore the location of the whole is actually at 3 and 1/7. So let's go back to your calculator. Remember, the graph, the whole is at 3. We can make it bigger. No, it does not. It's at 3. I'm trying to undefine. Now, how do we actually find the location of it? Well, we did the work, and actually I have prepared a coordinate 3 and 1/7, which was the result of our work a while ago. And actually that is where your whole is. It's just difficult to locate. There. And so if you look carefully, there it creates a circle with a hole, no unshaded circle inside. That is actually clearly presented as a hole on the graph. But for reference of location, we show the work and that the location of the hole is at 317, located by the red dot. Okay, it's just a location, but there is a hole that creates a gap, and so it creates a split of the graph of the function because that point is undefined. Let's have some more examples. Find vertical asymptotes and holes. We're not sure if there are more than one asymptotes. We're not sure if there are more than one holes. Remember, asymptotes are based on the values of x's on the unfactored, uncancelled factors on the denominator. Holes are found if there is cancelled factors. So it is possible that there will be 2 or more pairs of cancelled factors. Now, on your first example, the factor of x squared minus 2x is x plus 1, x minus 3. X plus 1 is cancelled, and so your factor is simplified as 1/x minus 3. And so your vertical asymptote is located at 3. To locate your whole, since it's cancelled, we can use the factor x plus 1 equal to 0. Minus 1 on both sides. Our x-coordinate of the whole is on -1. We will substitute -1 on the x of the simplified form of the function. And so it becomes -1 minus 3. -1 and -3 combines as -4. And so that is the location of the whole. If you're going to check on your own, on the Desmos calculator, there should be a whole at -1, -4. Let's have another example. So you have here find vertical asymptote and holes, x all over x squared plus 4. Actually, since x squared plus 4 is actually not factorable, there should be no vertical asymptote. Let's see if there is a hole. Actually, there's none. Since the denominator is not factorable, we can still try. Let's say, let's force it. Let's say, let's equate x squared plus 4 equal to 0. What happens? Subtract both sides by 4. It becomes x squared is equal to negative 4. To find x, we are going to perform the opposite. The opposite of square is square root. And so you are going to get an imaginary number. This is actually square root of 4 is 2. 2i. I represents square root of negative 1. And so it is imaginary. Since the vertical asymptote is imaginary, not a real number, then there is no vertical asymptote. There is also no hole, because a hole can only exist if there was a cancelled factors on both numerator and denominator. Okay. Third example. Find vertical asymptote in whole given the function x minus 5 all over 2x squared minus x minus 3. We can factor your denominator. This should be actually 2x minus 3 times x plus 1. The denominator. Nothing was cancelled. But we can still find your vertical asymptote by equating your two factors, 2x minus 3 equal to 0 and x plus 1 equal to 0. There should be two location of vertical asymptote. Add 3 on both sides for the first factor, minus 1 on both sides. You get 2x plus 2x is equal to 3. This is already done. X is equal to negative 1. Here, divide both sides by 2. The first vertical asymptote is located on the 3/2 of x, and the other one is on negative 1. Since nothing is cancelled when factored, then there is no hole. A hole can only exist if there was a there was a cancelled factor. Even if there's no hole, there is still possible that there is vertical asymptote. Actually, on this example, there is two vertical asymptote. Let's have probably our last example. Find the vertical asymptote and whole of the given function x squared minus x minus 6 all over x squared plus x minus 12. Both are factorable. On top, it should be x minus 3 times x plus 2. On the denominator, it should be x plus 4, x minus 3. And the x minus 3, you could cancel. Then we therefore have a whole. But let's continue. The simplified form of your function is x plus 2 over x plus 4. There is a vertical asymptote at x is equal to negative 4. Your whole is, of course, based on the cancelled factor. We will equate it to 0 to find the x coordinate of the whole. X coordinate of the whole is positive 3. To find the y coordinate of the whole, we will substitute 3 on the simplified form, not on the original, because it becomes undefined, because it creates a 0 on the denominator. So we are going to substitute 3 on the simplified form. So it becomes 3 plus 2, 3 plus 4. The numerator becomes 5, denominator becomes 7. Therefore, your whole of the function given is at negative 1 and negative 1/4. Let's check your Desmos calculator and see. This is actually, let's disable the other. Okay. And so this is actually your graph. X minus 3 was cancelled. Vertical asymptote is on negative 4 as well. It just happened they share the same vertical asymptote. It's just pure coincidence. Then where is our whole? It is on the positive 3 again. But it's on, I forgot, it should be at 5, 7. 3 and 5 over 7. I just did not include it anymore. Let's see if we can try 3 and 5 divided by 7, which is actually the location. It's also blue, which is your location of your whole at 3, 5 over 7. Okay? That's how you find the location of the whole. So to summarize, If x minus b is a factor of both of the numerator and denominator of a rational function, then there is a hole in the graph of the function where x is equal to b. Okay? It should not be that the b is a vertical asymptote. The exact point of the hole can be found by plugging b into the function after it has been simplified. There is no factor. If there is no factor cancelled, then the function has no hole. If there is no factor cancelled on the given rational function, then the function has no hole. Okay? If you need to review, just watch the video again. Thank you.